Hi, everyone. Welcome back. I know we had a little technical difficulty there with that first live stream, but Ev and I are back. And one of the things we were doing real quick was just introducing ourselves. My name's Heather, and I've been with TestOil for a little over 10 years now in a variety of roles, ranging from technical to now marketing. And one of the great parts of that is I get to combine my love of the technical oil analysis side with the creative side. And I also have Evan Zabowski here with me. And Evan, you can introduce yourself again a little bit.
Hello. Yes, I am the senior technical advisor here at TestOil, and I've got about 25 years experience in the oil analysis industry. I've had the opportunity to visit lots of different customers in different industries over the years, so definitely seen the good, the bad, and the ugly, and I'm just looking forward to being able to share some knowledge and wisdom today.
Great. So today's event is really about everyone that's on here. We want to answer your questions. We gave a category of test methods that best evaluate lubricant health. That's one of the kind of overarching categories that we tend to receive a lot of questions about. But we want to hear from you and answer anything that you are curious about or those burning questions that you have. So we did get a few questions ahead of time emailed over to me. So, Evan, one of the first questions that I received was, what is the most important test method to use when evaluating lubricant health?
That's a good question because everyone's always looking to pick the best test, and essentially there's five choices I would say. First and foremost is acid number. It's a very common test a lot of people do. It does monitor acid buildup in the oil, and it's a reasonable barometer for the health of the lubricant, because as acid number goes up, it means that the oil is degrading, and if you monitor this, you should expect to see that your numbers stay nice and linear, meaning that you get about the same amount of change with the same amount of service. So that one's a pretty reasonable one. It's an easy add-on for most people to do. But when you start looking at the other options, they're a bit more tailored towards the application. So there's two tests in particular, MPC and UC, stand for membrane patch colorimetry and ultracentrifuge. These are both tests that measure insolubles in the oil. And the thought behind both of those is that as the insolubles increase, so does the potential to create varnish. So varnish potential has been a name used to describe these tests over the years, but they're just another way of measuring a degradation byproduct that does appear in the oil. So if you've got systems that run at higher temperatures, higher speeds, they tend to be the ones most likely to create these insolubles, and would be perhaps an earlier indicator to trend these results than acid number would be.
Okay.
Yeah. Another test, though, that some people might want to do is RPVOT, which is basically, I always call it a kill test. It runs the oil through an incredible gauntlet of terribleness, and essentially it's trying to kill the oil as quickly as possible, and we time it. And if you trend those results, they do a pretty decent job at predicting the remaining useful life of an oil. But given the type of test that it is, it's only measuring antioxidant degradation. So your oils do have to have an antioxidant additive, of which many, many do. But the cost of the test becomes quite a bit higher than most testing. So people tend to reserve it for either very large volume systems or only occasional testing. They don't necessarily test every sample they pull from a system with that one. And then the last choice is ruler. And ruler is kind of the, I don't want to call it an up and coming test because it's been around for a while, but it's gaining popularity all the time. And what it does is it also measures antioxidants, but directly. So RPVOT basically, punishes them till they give up and sees what that takes. Ruler actually measures the quantity, and therefore gives you kind of a better perspective in some ways as to whether or not your oil has reasonable health, reasonable life left in it.
Mm-hmm.
And that one is tailorable to multiple oil types. So it does have quite a broad range. So like I said, those are kind of your five choices, acid number being, kind of everyone's go-to. But if you can add one more of those, that's great. If you add two more of those, even better. And of course, there's always people who want, all five, and they do that at least, once a year, just to paint the whole picture.
Mm-hmm. So we actually did get another question that maybe this is a nice segue into. They asked, are there certain tests that should be evaluated together? And you answered that a little bit.
Yeah, a little bit. And one of the things I always like to say about oil analysis testing is that no two tests correlate one to one, always go up, always go down together. Because if they did, why would we bother doing them? So yeah, the reason there's multiple tests is that there are sometimes correlations that don't exist and that you need to see it from more than one perspective. And sometimes it's just you can paint a better picture of it. So, again, thinking about those 5 tests, you group acid number and MPC together, you get an evaluation of your acids as well as your insolubles. And that, is a bit more comprehensive. On the other hand, if you paired acid number and ruler together, you would see how much antioxidant you have left, which gives you a hint at the life, but you'd also see how much acid you produced, which may be a bigger driver or a lesser driver to desiring an oil change. Because even if you have antioxidants left, it doesn't mean you're not building up acids. Mm-hmm. And if you're seeing that trend accelerating, then you know that that's going to be punishing towards your antioxidants, and one drives the other. So yeah, sometimes there's a nice complement in there, and sometimes it's nice seeing more than one perspective.
Right. Yeah, that's a great point. And I do see that we have a few people watching right now. If you have any questions, feel free to throw them in the chat. And Evan and I would love to answer any questions live that you have right now. And we can even have a little conversation at the time. But the next question that we got, because we did get quite a few, was which test methods help us understand what our oil is contaminated with?
Well, probably, everyone's go-to test for contamination is something like particle count, but that doesn't tell you anything other than how much you have in the oil and not really the what you have in the oil. So yeah, that's a good question. And obviously one of the things you're always going to want to check for is water content. And the best way to do that is through a Carl Fisher test method, because it actually quantifies the water. Now, in fairness, it doesn't identify the phase or the type of water. So if you're concerned about where the water is coming from and that you might have, either humidity or perhaps say cooling water as a choice, it doesn't get quite that far down the path. Mm-hmm. But the flip side is, what if you have solid particulate getting in there of some type and you're worried, where's it coming from? What does it look like? One of the better tests that's out there for identifying that is to do some form of microscopic evaluation. So analytical ferrography does a decent job at seeing some of these particles. And the nice part about that is it does focus on the wear metals that may be being created at the same time. So those are 2 kind of quick go-to contamination tests for all your common contaminants. But if you've got the weird, the unexpected, what is this weird looking debris on my filter, or yes, I saw some sludge at the bottom I can't explain, or I pulled a sample and it separated into 2 different colors, or something weird like that, then we actually have a service called material identification analysis, which is a really high-end sort of forensic type analysis. And if you're really curious about that strange looking contamination that doesn't seem to be the common ones, we can always take a look and try and evaluate an appropriate approach to figuring out what's happening there.
Mm-hmm. Yeah, that's actually probably one of my favorite methods. It's a little bit like the CSI of the lubricant world. Mm-hmm. So fun for us, not always fun for the other people. But on to our next question. And this is a really good one, actually, and a common one. But should I run the same set of test methods every month?
Well, one of the big things we always point out about just oil analysis in terms of data interpretation is that consistency is the key. And so you want to pull your sample from a consistent location. You want to use a consistent procedure to do that. You want to take it at a consistent frequency. And the biggest reason we say this is it drives the data to be as smooth as possible. And so if you're going to take the sample at a consistent frequency, you probably should run most of your tests at a consistent frequency. But in answer to the question, no, it doesn't necessarily mean you do every test every time. Mm-hmm. But what it does mean is that you should have every test on a pattern. So there might be some tests you do monthly, some tests you do quarterly, and some you do maybe semi-annual or annually, depending on the life of the fluid. But in general, yes, you want to make sure that you don't just like, as an ad hoc decision, decide to add one test one time and then not bother with it another time. It makes it very hard to trend the data. And some of the value of oil analysis is really only realized through trending rather than just a singular result, out of one sample. So, and I guess I'm not really answering the question directly, but it is saying you should run every test consistently. You should ask for it at the same intervals, and but bearing in mind that some tests are more expensive or are a bit more detailed, yeah, you can choose to do those ones like every third or every fourth sample. But generally speaking, yes, you want to do most testing on most of your samples every time you pull a sample.
Right. That's been my experience when reviewing reports for various types of fluid analyses. Just that, to reiterate, when you have a sample that you are seeing every 1 month, and then all of a sudden there's a break in the program, and you get a sample 6 months later, and all of a sudden that sample has an alarm of some sort, whether it's on the lubricant or the machine condition itself, it's very difficult to pinpoint what happened in that 6-month time span, because so much time has passed at that point.
Yeah, for sure.
So one other good question around kind of test package and schedules is, can I test my oil with a smaller test package monthly and use a more extensive test package every 6 months?
Yeah, that's kind of exactly what I was getting at there, that you may choose to, balance your budget, so to speak, and not do, the expensive test every quarter and sort of split the money up and do less testing every month, so you have a closer eye on some of the common things, and then do those expensive tests a bit less frequently, like every 6 months. And ultimately, at the end of the day, your annual budget for oil analysis for the year hasn't really changed, but the value of your program has probably increased a reasonable amount to justify making a decision that way. And really, to that end, it's one of the things we always point out about setting up a program is you almost give the same thought for which machines that you are going to pull samples from, that you don't necessarily do the same testing on every single machine that you're going to take samples from. That, yeah, you might do some machines more frequently, some machines less frequently, because you want to balance the bang for your buck in terms of that budget and say, where is the value? Which machines need closer monitoring, just like which tests need closer monitoring compared to which ones you leave less frequently because they're less prone to change.
Right, exactly. So we've been talking about test packages, and let's talk about, we got a couple questions in about the difference between a few different test methods. The first one is, what is the difference between the two acid number methods? And they mentioned ASTM D664 and ASTM D974.
All right. Well, 664 is the one that's known as the potentiometric method, and 974 is the one that's known as the colorimetric method. And we tend to default to 974, to the colorimetric method. And one of the real simple reasons behind that is when you read up on the ASTM standards, both tests use all the same chemicals at all the same ratios. The setup is the same. The basic procedure is the same. They're both titrations. And for those of you who can remember back to your high school days, you might remember that you played with acids, you played with bases, and really what you did was you neutralized them, right? You poured one into the other and you could neutralize the reactions. We're doing the same thing here. And if you remember high school, you might remember that when you did this, it turned from clear to pink and back again. And it was because you were using a color change indicator. Well, we're doing the same thing, but we're using a slightly different color change indicator. But anyways, it does change color. And with the colorimetric method, we're measuring how much acid is in your oil by actually taking a direct measurement of how much base did we have to add till we saw the color change. With this method of waiting for the color change, ASTM would suggest that it's about 1/3 of the error compared to the other method, the potentiometric method. And the potentiometric method still pours a base into the acid to measure how much is there. It does all, like I said, all the chemistry is the same. But rather than a color change, it's looking for what we call a potential change. It's using essentially a conductivity meter to measure for an electrical change within the fluid, to measure the ionic difference that happens when you neutralize acids and bases. So ultimately, at the end of the day, they're very, very similar measurements,
Hmm.
but we find the accuracy of the colorimetric method is better than the potentiometric method. And the nice thing is that in the old days, you used to have to do colorimetric manually, and it was more time consuming. Today, of course, everything's automated, so
Right.
we're not suffering on speed. So, like I said, that's why we tend to favor that one. But
Hmm.
in answer to the question, no, there's not a strong difference between those two test methods.
So, and I see that we had a question come in from Nora. So I'll just pull it up on screen real quick. And she said, "Hi, Heather and Evan. I have a question that came in. I see foam in my gearbox. Do I need to change the oil?"
Well, that's a good question. Because of course, some people when they say, "Do I need to change my oil?" they just mean, take out the old oil and replace it with the kind of oil they had in there in the first place.
Mhm.
Sometimes it could be the oil's fault. So one thing you might want to evaluate is what is the reason behind this foaming. So first thing you probably need to look at is just oil level. If your gearbox has been overfilled, it will have a tendency to foam because you're going to be churning the oil in a way that wasn't really part of the design. And so something as simple as simply draining off a little bit of oil might actually clear up the foam problem and save you from actually needing to change the oil. But if you do see that, no, the oil level looks okay, aside from the foam, of course, then what you might want to do is evaluate if a contaminant is causing the foam to appear. Like, as an example, something as simple as water. If there's been a lot of humidity buildup in the gearbox, that could drive the oil to start producing a little bit more foam, but as well, even particulate. Sometimes that helps the oil entrain a little bit more air. And if it's not ridding itself of the air as quickly, then it may have a tendency to form more foam. And in that case, the short answer would be yes, you could either filter your oil if that's possible, or just simply change it out if it's a small
Hmm.
volume. But on the other hand, the third option is if your level's fine and your oil analysis results come back okay, and you're not really seeing any logical reason for an obvious foam problem, you might have to look into your lubricant choice. And maybe that lubricant isn't a proper lubricant for the application. And it could be something just as simple as the viscosity choice. So you may need to literally change your oil, as in change which oil you're using, to be able to clear up that foam problem. So, step one, start by looking at the level. Step two, look at back on your recent oil analysis results and see if there's been an abnormal trend in your contaminants before you get too gung-ho about scheduling that oil change. Because as I always try and tell people, oil changes don't fix mechanical problems, right? They just
Right.
basically they wipe the slate clean, and you think the problem's gone till it comes back again.
Exactly. That's very true. Um, I completely agree. And I can't tell you how many times we've had similar questions or experiences from our customers. They send in a sample to the laboratory. Lab test comes back great, no foaming of the oil under lab conditions. So that leads us to believe that there's usually some sort of mechanical issue at that point rather than contamination issue. And it's nice to be able to use that to start heading yourself in one of two directions.
Mm-mm.
Let's see. All right. So another question that we had come in was, and this one's a little bit of a doozy. How are alarm limits determined? Because that's a kind of a big question there.
Yeah, that is an interesting one because there's multiple ways to do this, and the first and foremost is just saying statistically. I mean, obviously, somebody's got to have some justification behind an alarm limit. So statistics usually come into play somewhere along the way. Now, with certain properties that we have, like a straight physical or a chemical property, often limits can come right from the basically right from the people who manufacture the oils. So, as an example, viscosities are graded. And so there's grading systems. There's an ISO grading system, there's an SAE grading system. Each of those grading systems comes with a limit for what defines the grades of oil. So,
Mhm.
from a viscosity perspective, there is no worry about setting a limit. There simply are limits. When you think about something like acid number or another chemical type property, the limit is often driven by not so much a hard and fast upper, line in the sand kind of limit. It's more about either a rate of change or a time between a flat trend and a sudden increase.
Mhm.
So when you see that once, and this is where the statistics come in, you start to establish a data point that says, hey, we notice the acid number can get about this high before it suddenly takes off. And if you have a number of observations, it doesn't even have to necessarily be similar applications or similar machines, you can start to establish a limit that way.
Mm-hmm.
And those ones can come from lubricant suppliers or OEMs to a point. But when it comes to other things like wear metals, there's a great example. People always want to know, how do you set a wear metal limit? How do you know how much is too much?
Right.
That gets a lot more difficult, because one of the things people don't necessarily take into account or realize with these values is that they are a concentration. And it's not really an amount of metal, it's a concentration. So it's an amount per volume or per weight.
Mm-hmm.
And so one of the examples I always give is, if you imagine 3 different systems, one's 5 gallons, one's 50 gallons, one's 500 gallons. So as you can see my pattern here, they're all an order of magnitude of 10 greater than the next one. And if you ask yourself, okay, if you had about the same amount as 2 fingernail clippings, so, kind of gross, but bear with me here, about 2 fingernail clippings worth of material in 5 gallons, and you compare that to about 3/4 of an ounce of material in 50 gallons,
Mm-hmm.
or a half a pound of material in 500 gallons, I always challenge people, say, which one's worse? And, different people pick different things, but a lot of times they tend to lean towards, well, geez, a half a pound, that's a lot of wear metal, or say it's just even dirt. And so
Mm-hmm.
they always say, that's the worst one. And I go, well, see, the problem is that those 3 examples I gave you all calculate out to be 100 ppm.
Mm-hmm.
So when people want to set a limit and say, well, is 100 ppm too much? It's the running joke is, well, depends on the volume, because, 100 ppm in 5 gallons is really not a lot of material. It doesn't take much to get there. But 100 ppm in 500 gallons means you've, like, say it's a gearbox, you've already lost a whole tooth, right?
Right, exactly.
So the better way to do it is per machine, per type of machine, at least, of equal sump volume, look at statistically where it seems to go from, again, a flat trend to an increase, or where just it seems to be suddenly correlating with something else.
Mm-hmm.
So if you've got bearing wear, which you would expect, then you watch the bearing wear slowly increase over time. Now, as soon as you start to see evidence of shaft wear, now you've gone too far. And again, statistically, you would set that as a data point to say, okay, let's never get that close again. And you back that off and you set a limit. But there's a lot of other tests out there with other ways of setting limits. But ultimately, at the end of the day, most of them are either hard and fast rules.
Mm-hmm.
There's general guidelines, or a lot of them are set statistically based on a trend, based on the machine itself. And so I caution people for trying to look for those magic numbers where they can find that one value they can apply to everything in life. It's like, oil analysis doesn't really work that way. It's best to monitor each sort of group or fleet of machines individually, and not try and group all your pumps together or all your gearboxes together, because there are too many variables to really safely say what's the limit.
Right. I completely agree. And looking at the time here, we'll do one more question from my list. So I know TestOil uses pore blockage and laser particle count together for some analyses. What's the benefit of using these technologies together?
Well, I guess the short answer is that with pore blockage, the type of particle count that is not influenced by anything in the oil. Mm-hmm. So water molecules, air bubbles, and soft contaminants are the 3 that we list most frequently as things that may actually affect a laser particle count. And the problem is that by the detection methods, a pore blockage particle count is done by a physical measurement. It's by pushing the oil through a screen at a constant pressure and measuring the flow decaying on the backside of that screen. So the only thing that should be piling up on that screen are truly solid, or what we consider to be hard particles. Laser particle count can be fooled to an extent, depending on sample prep, with some of these what we call softer particles. And like I said, they could be water molecules or air bubbles too. So when you compare both sets of results, what you're ultimately seeing is the amount of particle count that you get from pore block, you would attribute all of that to hard particles. Most times you're going to find the laser particle count will be higher, and therefore you can treat the difference between what the laser particle count is and what the pore block particle count is, as those are all the soft particles, because a laser particle counter will also count the hard ones too. But
Right.
what you're seeing then is, do I think I have a lot of soft particles?
And
And
soft particles, that can include sludge, varnish, water
yeah,
droplets, air bubbles in the oil, correct?
yeah,
So that's something to keep in
any
mind.
insoluble, so any degradation byproduct, and then yeah, air bubbles and water molecules. So all things we don't like to see.
Right.
Right?
Keep the oil clean, cool, and dry, right? That's what we
Exactly.
like to do. So it doesn't look like we have any other questions live right now. And we're coming up at the end of our time. So I want to thank everyone that has joined us. This will be available on our LinkedIn page. I'll also toss it on YouTube so you can go find it anytime on our YouTube channel. But Evan, thank you so much for sticking around, answering some questions. And if anyone thinks of questions after the fact, you can email Evan at ezabowski@testoil.com, or you can always email me at hpersillo@testoil.com. Otherwise, thanks for your attention, and I hope everyone has a great day. We'll see you later, Evan.
Right. Thank you.
Bye.
Bye.